Okay, so this is an example of a question that we can solve. This is from the internet. Now, if you look at this question, you can already see that this is a square that is singular, and then this is power 0. So you can already see that this is quadratic equation, right? You can actually solve this by replacing this maybe with another variable, but I think this is simple enough to solve straight away. So remember what is important when we're solving is the reference angle. We also need to get the ASTC, okay, which is all sine, then tan, and then cosine, okay. So these two can help us to solve. The rest is just normal algebra. So here we're going to have 4 sine squared theta minus, we know that the product is, sorry, we're not yet at the product state. This comes this side and subtracts with this. So we have plus 1 is equal to 0. So now this one and that one can multiply. We get the product of 4. And so we want to get the sum of minus 4, this sum here. We remember the quadratic equations. And so the factors are going to be minus 2 and minus 2, because this by this gives us 4. Then this plus this gives us minus 4. Right, so we continue to solve. So this one now becomes 4 sine squared theta minus 2 sine theta minus 2 sine theta, then plus 1 equal to 0. I can factorize 2 sine theta this side, okay? Then I get sine 2 sine theta minus 1. Then here I can factorize 1 minus 1. Then here this one will be positive, so which is 2 sine theta. Then minus 1 equal to 0. Okay, now this is going to be 2 sine theta minus 1, and then 2 sine theta minus 1. We'll actually just use maybe y or x or whatever, but it's simple enough to be solved this way. So now we can say that this and this are the same, so we can just use 1 to say 2 sine theta equal to 1, and then sine theta is equal to half. Okay, you can show by saying that theta is equal to sine inverse, then half, like that, meaning that you're trying to find the value of this. Now, there are certain values from the trig circle and whatever. You can use that, okay? Or you can actually memorize the trig values of special angles, okay? That is something that you can just look at and memorize. So the value of this one will give you theta is equal to 30 degrees, or 30 degrees is actually pi over 6 with our conversions, okay? Now, this is not the final angle in trig, and this is why we had to go through a series of theory for us to know. This is actually what you get. What you get in trig when you solve is actually your reference angle, okay? So now, if this is our reference angle, the first thing that we need to do is that we check for where this is actually positive, because we can see that this sign here was positive. So we said that all students take calculus, right? So here we have O, and then here we have sine, okay? And then here we have tangent, and then there we have cosine, right? So if we have these ASTC, okay, if we have ASTC here, we can see that we have sine positive here because all of them are positive, and then sine will be positive there, meaning that the angles that we're going to find, the domain, because we're looking for theta, is just going to be there and there. But we have to use the reference angle. So now let's look at this. If it's here, we say that that's the same angle. So theta here was our angle. So we can say that now theta, in terms of our answers, is going to be pi over 6, which is 30 degrees, right? Which other angle can we work out? Because we're looking for positive, sine here, right? But then it'll be here. Again, we're going to look for it here. And our theta, which is our reference angle, is going to be there. So meaning that the angle that we're looking for, okay, not this theta, maybe I can say our r. We should have worked this out as r, okay? So it's going to be that angle there. Meaning that this, we said that this angle is actually going to be 180 minus theta, or the reference angle. We're using theta everywhere, it's fine. It's going to be 150 over 180. Okay, so this is going to be 5 over 6 pi. So this is going to be 5 over 6 pi, right? Why? Because it's we are taking away the reference angle here. Remember we said that it was 180 minus theta, but theta in this case is the reference angle here in this case. Okay, so the best way to look at it is that when you solve trig equations, what you find at first is almost like your reference angle, and then that you use to find your actual angle. So it's going to be that angle there, and then it's going to be this angle here. Okay, but we say that this angle is actually that angle, and then this angle is actually this one. So these are our solutions to this problem. Let's look at question number 2.